Hi there, I'm the narrator, and I'm going to take you through the issue of groundwater and its use as a freshwater resource. First, I will talk to you about water, how abundant it is, and in retrospect, how much of the water on the planet is actually groundwater. I will also talk about the science behind these large underground reservoirs and where they are located, how much groundwater we consume per year, and our uses and values of this water resource. So, how much water is actually on the Earth? Well, from the US Geological Survey's website, approximately 70% of the Earth's surface is covered by water. 96.5% of it is saline and undrinkable. Of the rest of the water on the Earth, less than half of that 3.5% remaining is actually groundwater. And 30% of the fresh water on the planet comes from underground aquifers in comparison to the 0.3% of fresh water that comes from typically lakes and rivers. This easily demonstrates that we can use more water by getting it from groundwater sources rather than surface water sources. Only one problem with this: it's in the ground. So stop looking at that ground. No matter how long you look at the ground, you won't see any water unless it rains or a miracle happens. Now that we know how abundant groundwater is, where does it come from? Well, when it precipitates, e.g. rain, snows or hails, the water soaks into the ground. The water that is soaked into the ground eventually moves down further into the ground by gravity. This is called percolation. When it does this, it passes through all the cracks and holes of sand, gravel, soil or rock until it reaches a saturated zone, which is filled with water. The top of the saturated zone is called the water table. Both groundwater and surface water share a very unique role in providing water for an ecosystem, as they both can swap positions. So, groundwater feeding a lake or river, or a lake or river sinking down to the ground to become an underground aquifer. These are some maps showing some of the major groundwater reservoirs in Australia and the United States, with the largest in Australia the Great Artesian Basin in Queensland, and the Ugala Aquifer, also known as the High Plains Aquifer, in the United States. There's a little bit of the science of groundwater for you. So now we know how abundant groundwater is and the science behind it. But how much do we consume of it, and for what purpose? Well, in Australia we use a total of 24,000 gigalitres of water per year. 19,000 gigalitres of it comes from surface water sources, whilst the other 5,000 gigalitres of it comes from groundwater sources. Did you know that we Australians individually consume approximately 250 litres of water per day? Geez, aren't we a thirsty lot? And our American counterparts consume approximately 400 litres of water per day. Crikey! They are even thirstier than we are. However, in the past, the amount of water that we use individually was much higher, approximately 350 litres of water per day. Remember that number, 24,000 gigalitres? Well, we Australians use the majority of that water towards irrigation, so stable crops, cattle and other agricultural industries. Now we definitely know that we use 5,000 gigalitres of water in Australia from groundwater sources. But is that too much? Well, there are two main sides to this issue. The first, that we are taking too much water out of the underground aquifers for them to recharge and for it to be sustainable. And the second, that there are laws and regulations in place that limit the amount of water that has been taken out of the underground aquifers. And that we cannot possibly be depleting this natural resource when you look at the sheer size of many groundwater reservoirs. These are obviously two very different arguments. Let's start with the second argument. We're not consuming too much water of this resource, as its size is too great for us to deplete it, and our laws protect us from such action anyway. Well, they are right. There are many laws and regulations that protect the quality of groundwater and the amount of water taken out of these aquifers. For example, in the United States, the Environmental Protection Agency, or EPA, sets laws and regulations to protect groundwater reservoirs. Some of these include the Safe Drinking Water Act, the Clean Water Act, and the Resource Conservation and Recovery Act. However, despite these laws and regulations supposedly protecting these water resources and using them sustainably, there are still events around the globe where many underground aquifers are under threat of being depleted. This support is supported by the recent UNESCO report stating that the world's underground reserves were being depleted rapidly. For example, the Ogallala Basin in the United States is under great threat of being depleted, as many states that surround the basin are trying to get as much as they can with the rape and pillage attitude. Also, the report Groundwater and Global Change Trends, Opportunities and Challenges stated that the Great Artesian Basin in Australia is suffering dearly from overuse of boreholes and wells. That part really supports the first argument's case. We are taking too much water out of the groundwater reservoirs for them to recharge and to be used sustainably. However, there are many plans, such in Australia, to refill or top up underground aquifers with recycled water in order to use this water resource sustainably. Peter Dillon, a senior science researcher from the CSIRO Land and Water, states that many sources of water can be stored in groundwater reservoirs and potentially later on be used for drinking water. This is one of the many ideas that could potentially be used for sustainable use of groundwater. Anyway, the purpose of this short video is to inform you of one of the many environmental issues that we face today, and for you to give you a general idea of the facts. In conclusion, do not take this video as reporting the absolute. Go out there and research this topic and others for yourself, for knowledge is power.